Okay, good morning, guys. Today we're going to be working in Nearpod and we're going to be talking about the real number system. So, real numbers, imagine if you would, we have a big bucket and it's made up of all real numbers, right? And inside that bucket, we have other number systems. So with that, inside real number system is irrational numbers and rational numbers. That's kind of like the first category breakdown. So imagine if we took um, a piece of plastic and we put it in the bucket and we cut it in half. And half the bucket would have irrational numbers and the other half would have rational numbers. So what is the difference between the two? Well, you can see here we've given you some examples. Irrational numbers would include the number radical 2, and we've written them as decimals there. So you can see that pi is never ending and non-repeating, and so is radical 2. Rational numbers include the numbers 1/3, 0.5, 2/9, 0.875, 1 3/4, and of course 0.3 repeating. Integers, we've had some examples there, and you'll notice that it kind of like goes in. So irrational numbers are kind of by themselves, they're half the bucket, and in the other half is rational numbers, and inside that rational number bucket or part of the bucket is integers, which you can see include negative numbers, the number 0, positive numbers. Inside integers would be whole numbers, including 0, 1, 2, 3. And then inside whole numbers would be natural numbers. So in math, when we categorize something, either when we're getting like smaller, either it's because they have more conditions or they have less attributes. So in this case, it's going to be the rational numbers is hit big, and then we get smaller, we get smaller, we get smaller, because the conditions to fit into that category become stricter. Okay, like for example, we're all people, right? We're all humans, male, female, whatever. Then we could break it down by gender, male, female, you know, some other things in there too, but we're going to stick with just male, female, and then we can go to girls that are, blonde hair, girls that are dark hair. All of those could be different categories or different characteristics helping you to categorize something. So that's the same thing with number systems. If we look at their actual definitions, so irrational numbers is any number that cannot be written as a quotient, ratio, or fraction. And quotient would be like division, ratio, 2 versus 1, fraction, a numerator over a denominator. But basically, these are all methods to compare numbers. We have one number in relation to another. The decimal form of a rational number neither repeats or terminates, so it's considered never ending and non-repeating. That we saw that with pi. If we punch that into our calculator, we just have digits keep on going. Rational numbers, on the other hand, are, as you would expect, the exact opposite. It includes all numbers that can be written as a fraction, a quotient, or a ratio, where a and b are integers and b cannot be equal to 0, right? Because we're not allowed to have 0 in the denominator of a fraction. That is undefined in math. Integers include both positive and negative whole numbers, and it also includes basically negative infinity through positive infinity, including the number 0. Whole numbers include all the positive integers and the number 0. And then natural numbers only includes positive integers, so 0 is not included in the natural numbers. So all of these make up the real number system, which may seem odd to you because pretty much through 5th, 6th grade, you've been working in what's known as the decimal or the base 10 number system, which base 10 would all fit inside rational numbers as well, where we use the digits, and basically what that means, we're using the digits, 0 through 9 to build our numbers. And the focus is on place value within the decimal number system. So later on, you'll learn about imaginary number systems. So there's multiple number systems, and sometimes they're used for specific purposes, or basically they have certain descriptions that make numbers fit into that number system. But we're going to be concentrating on the real number system this year in 8th grade. So hopefully that gives you some basis in the real number system and allows you to answer the questions on the quiz coming up on the next slide.